Okay, let's go ahead to the first lecture, tropical number system. Unlike the usual summation and multiplication, in the tropical world, the summation and multiplication is a little quite different. So let T is defined by extended real number valued system, which means that R union minus infinite, and define a tropical sum A check A B in T. Define the tropical sum is defined by maximum between two numbers, and multiplication is the natural addition as in now. Then we call this a tropical number system. Okay, that is the definition. But the notation is by others, the notation is a slight different. Some mathematicians use the scale in plus in with scale, and instead of circle, instead of product notation, just dot point. And another textbook uses the question mark. That is a tropical sum, and that is tropical multiplication. In this Tübingen University textbook uses this notation. But anyway, we should check that this system is whether the system is well defined. That is very, very important. If it is not well defined, it is not useless. To check the well-definedness, one standard basis is to check identity or inverse, existence of the identity and inverse, each summation, each operation. But in case of the tropical multiplication, it's just addition, as we know. That is okay. But we should think about in case of a tropical summation, whether the identity or inverse exist. Or other properties are commutative law, associativity, and distribution law, and so on, to check this system, to verify, to check the system is well works. Okay, check the identity. For example, what is the identity? In case of group system, if operation is given, if this relation holds every A in G, we call E an identity of E. Okay, let's check this. Apply this property to a tropical operation. That is that here. In fact, a tropical summation naturally satisfies the commutative law. Okay, so we should check one of them, which means that for all A, in that case, A is T, and E also in T. Okay, then we should find this result for every A in T. If we plot the graph, horizontal graph, if A is given here, and to satisfy this equation, identity E should this part. Okay, then whether A and when comparing to A to E, A is maximum. But note that for every tropical number that holds. So if A is here, then does not hold. This part does not hold. So the E should move the left. Then okay. But A also can move here. So to hold this equation, we should extended real y, the extended real number valued system, as I said, y that is essential part to consist of tropical number system. To hold this equation, the result is the only way to hold this equation. E is a minus infinite. So whenever A comes to here, the result is always A. Okay. So identity of a tropical number system is minus infinite. Of course, as I said, multiplication, tropical multiplication is just natural user addition. So this is trivially exists the identity and inverse element. Interestingly, when we investigate the inverse element of tropical sum, I only focus on the tropical sum. For example, let's see this equation. When we solve the tropical summation equation here, and when comparing to the linear equation, as you know, okay, that means that the definition is here. But this equation is not the equation, because if x is greater than or equal to 3, by definition, that result is 3. Otherwise, that is, that is x. And in that case, that is 3. Whenever the x comes, the result does not 1. So then in this case, does not a solution. So this is not a equation. In this, that means that the inverse of tropical multiplication does not exist. Why? If we solve this linear equation, the reason why we can obtain the solution is that we can adding an inverse element or sum, use a sum, due to the existence of the inverse element. This guy's to be 0. 0 means that identity of the user sum. So we can obtain the solution. If the inverse exists, we can obtain the solution. This solution, but that in that case, the inverse in the tropical number system does not exist in general. That is important part of the tropical tropical system. Okay, inverse element does not exist. Okay, as I said, a tropical number system commutative law is obviously hold maximum A between A and B and maximum between B and A is the same. Okay? And associative, in case of associativity law, associativity law, tropical sum A plus tropical sum B, C is equal to this here. For every tropical number system A, B, C, T. That is easy to prove because by definition, we can give an order. So without loss of generality, let A, B, C, we can obtain the result of associative law in a tropical number system. Finally, distribution law also satisfies, which means that in that case, tropical multiplication and tropical sum, okay, that is here. So okay, yeah. So so the tropical number system, except for the inverse, quite a reasonable number system.